We're going to go through this first problem together, A, B, and C, all right, because this is it's a good setup for how to solve Newton's second law problems. We've done a little bit of work with it. I think that if you looked at a problem, you'd have a decent idea of how to solve it, like doing the clicker questions. You have a decent idea on how to do it. But now we need to go through and kind of formally get understand what's going on, okay? So we've got our box here, and they give us this free body diagram of 75 newtons going up, 75 newtons going down. We have F going to the right, and we have 17 newtons going to the left. Okay? Force, some random force. F is some random force. That's what they want us to find eventually. Okay? So part A asks, what is F if the box is moving at constant speed? Okay? So you just did it in your head, right? But we want to be able to write it out. Okay? So what does constant speed tell us? Okay, so it's in equilibrium, then what is zero? So the net force is zero. Good. So the net force is zero, then what else is also zero? The acceleration. Good. So if constant velocity means the object is in equilibrium, equilibrium means the net force is zero, the acceleration is also zero. Okay? So we start by just writing Newton's second law, right? F net equals ma. And because F is in the x direction, that's where I'm going to start. And all I do is I write down the forces that are in the x direction. So I have F and I have 17. Okay? F points in the positive x direction. So because F points in the positive x direction, I'm going to leave it as just F. 17 points in the negative x direction. So I'm going to make that 17 negative. So it becomes F minus 17. Okay. Do we know M?
No.
No, we don't know the mass. In this problem, it doesn't matter, but we should know. We should be able to find it. Okay? We know the weight of the box, correct? The weight is the arrow pointing down. So if we know the weight, we can find the mass. Remember that weight is equal to mass times gravity. So the weight is 75 newtons. And we have m, and then we have gravity is equal to 10. So the mass of the block is 7.5 kilograms. Negative just means it's pointing down. Just means it's pointing down. No, because we're going to take care of that in the equation. Okay. So I know that m is 7.5, and you told me that the acceleration is equal to 0. So I popped that in. Okay. So when I do the math out, then I find that, solve for F, I find that F has to be 17 newtons. Okay. The net? Oh, so F net is equal to F minus 17. So net is the sum of these two forces. Okay? In this case, the net force is 0 because 17 minus 17. Okay? So that's part A. Part B then says, find F if the box has an acceleration of negative 1.3 meters per second squared. So we start the same way. F net equals ma. Have our forces changed at all going from A to B? They haven't, right? So I can write the same things here. I can write F minus 17, right, equals 7.5. And what's the acceleration in this problem here? Negative 1.3, right? For part B, they tell us it's negative 1.3. So I get F minus 17 equals negative, what's 7.5 times 1.3? Anybody know? Okay, so negative 9.75. Okay, so now I'm going to add 17 to this side. And I should get 7.25? Sound about right? Yeah? Okay. So we find that F is 7.25 newtons. So let's think about this. This is a good place to check. So that means right here, F is 7.25 newtons. The other force is 17 going to the left. Which direction is the net force pointing? Left or right? Try again. To the left, right? The net force is pointing to the left because 17 is greater than 7.25. Okay? So that's the direction that the net force is pointing in. Now, is that the positive x or the negative x? Negative x. So we have a net force pointing in negative direction. What direction does the acceleration point in? Negative as well, right? Right there, negative 1.3. So here's the check. If you did it correctly, we should have a net force pointing to the left, which you told me we do, and that needs to match the acceleration also pointing in the negative direction. Follow me? Okay. Remember, force and acceleration have to point in the same direction. So we had a greater force pointing to the left, negative, and we have, again, a negative acceleration. Okay. If you get them a positive force and a negative acceleration, something went wrong. Okay. Positive net force, I should say. Okay. So you got to, again, find the direction of the net force. Look at the two forces that were in the direction of however many forces we have. And what is the direction of the greater force? Okay, good? All right. Then let's look at part C. Come on. C asks us, find F if the box has an acceleration of positive 2.5 meters per second squared. Okay. So we have F net equals ma. Again, same thing all over again. Has our forces changed? Have our forces changed? Still all the same ones for this one, right? So we still have F minus 17. The mass is 7.5. Now A was 2.5, correct? A is 2.5. So we do the same thing. What's 7.5 times 2.5? 18.75. Okay. So when I add these two, right, 7.5 and, yep, 2.5. So 17 plus 35 plus 0.75, and that's newtons. So again, let's check. We got that the F, right, the force that's pushing the box is 35.75 newtons. So this is, so this is 35.75, this is 17. Which direction does the net force point in or push in? In the positive direction, right? Because it's greater. Is the acceleration also positive? So that checks out. They have to, yeah. And we saw that in the experiment we did, right? That the force and the acceleration always have to be in the same direction. Okay?
When it says, like, you know how it says, when you set up the equation, it says m naught and stuff, is that always when you, like, adding and subtracting?
Yes. Yeah, so F net is just the sum. So we either add or subtract.
Okay.
Yep. Okay? Good? Everybody good?